In this video, you're going to take a look at what's involved in migrating a traditional web service running on IIS to become a cloud service running on Windows Azure. We're going to take this price history service, PH service, which is a standard ASMX-based web service, and we're going to migrate it to become a cloud service. If you're familiar with web services, you'll be familiar with the test harness for ASMX web services, where you can go in and you can pass parameters to it. And in this case, it's a price history service where we can pass it the stock ticker and some dates like a start date and an end date. And when we invoke the web service, what the service will do is it'll go and return XML for price history, and that's the opening price, the closing price, the high price and the low price of the stock traded on that particular day, as well as the volume of the stock on that day. What this service does is that it provides a front end to Yahoo's financial services, and Yahoo's financial services provide the data in CSV, comma separated value format. So what this service does is very, very simple. It just wraps all of that. Let's take a quick look at how it works. So our web method that we just used is called getPriceHistory as string. And what this web method does is that it calls this getXML function on our helper classes. And we can see our helper classes are defined in helper functions. We'll look at them in a moment. And it just passes the ticker, the start date, and the end date that was passed in by the user, gets the data back as XML, and returns that data to the caller. Instead of passing an XML document, we're just passing a string containing the XML over the wire, and it makes it a lot easier for us to parse it on the other end and to interoperate on the other end. The helper functions that we mentioned are simply a class. And this class has the getXML function that we saw earlier on. What that does is it creates an XML document, it creates a data set, it builds up the URI for Yahoo that provides the data in CSV format. So Yahoo, if I scroll down here, on the ichart.finance.yahoo.com table.csv (S equals) requires a bunch of parameters. The S parameter is the ticker, the A parameter is the start month, the B parameter is the start day, etc. So what this function does is from the date that was passed in for start and end, it just splits it out into day, month, and year, and gets the ticker, creates this URI, and returns the URI to the caller. So syahoo URI is the URI that you're going to call to get the comma separated values data back from Yahoo for the specified ticker between these two dates. A web client is then opened and the contents of the URI are read back into a stream, and then a data set is generated from this stream. The reason why we use a data set is just it's much easier to use a data set object in .NET to create values out of a comma separated values. I use it simply to parse the comma separated values. So the dataset result is created as a result of the comma separated values coming back from Yahoo. And then a string writer and an XML text writer are created, and the contents of the dataset are written into the XML text writer. And then that gives us an XML document with the representation of the contents of the dataset. So we're taking, if I look at generate dataset, what we're doing is we're taking the comma separated values from Yahoo, reading them into a dataset object, and the dataset object allows us to serialize the contents of the dataset out easily as XML. So we get that XML and we return it back to the caller. So this function getXML calls the Yahoo service, gets the comma separated values back from the Yahoo service, and generates that as XML. And that XML is then returned into this XML document called xreturn, and then the XML content of that is formatted as a string to be returned over the wire to the function that was calling the service. So if I go back and I execute it again, you'll see the results of that. If I view it in the browser, here's the method within the test harness, and if I say MSFT and I want to go from 1/1/2013 to 2/1/2013, and I invoke this, we'll see that the content has come back. Here's my data set, and within the data set are time series, and each time series contains a date, open, high, low, close, etc. So this string could be read by a client, read into an XML document within the client, and then once that happens, you can parse that XML, and we'll demonstrate that in a moment once we migrate this to a cloud service. So the first step in turning this into a cloud service will be adding a Windows Azure Cloud Service project to our solution. To do this within Visual Studio, we just go to our solution and say Add New Project. And within the templates, we'll see there's a cloud service template called Windows Azure Cloud Service. And as our project was called Price History Web Service, I'm just going to call this Price History Cloud Service. The wizard will then give us a number of options that we can create. I'm using Visual C#. We can create an ASP.NET web role. We can create MVC web roles, WCF service web roles, worker roles, etc. But because this is a service-based project and I'm building a cloud service, I'm just going to use a WCF service web role here. And I'm going to add that to the solution. And I'm going to give it a name. So here I can say the PH service web role. That's what I'm going to call it. I'm going to say OK, and then Visual Studio creates the service for me. So we'll see here within Visual Studio, two projects have been created. One of them is the cloud service itself, including all the metadata for the web role that Windows Azure needs to be able to scale your service for you. And then the other one is the implementation of the service itself. The other one here is the implementation of the web role for the service itself, including the interface to the service and the implementation of the service. If you've ever built in WCF, this will look immediately familiar. So what I'm going to do first is, within the implementation of the service, we'll see the boilerplate has created for me a couple of operation contracts. These are like prototype functions for the web methods that your service is going to expose. So if you remember, in our original service, we had a web method, if I go back down here, that was called getPriceHistoryAsString, and the signature of the function looked like this. What I'm simply going to do is copy that and go up to my new interface for my new service, and I'm going to create an operation contract with that signature. Like that. So now my new service running within Azure is going to have an operation called getPriceHistoryAsString, taking these three parameters and returning a string. So let me save that out. So the next thing, of course, that I have to do is then implement this. And you implement this on the SVC file. So here I have my service1.svc, and if you recall from my interface earlier, I had prototypes for get data that returns a string and get data using data contract that returns a composite type. And if I look at my service1.svc, we can see get data returning the string, the actual implementation functions here, and get data using contract returning a composite type. So what I now need to implement, of course, is my method, the one that's going to be getting the data and returning it as XML. And as I've written the code here already in my web method, my original web method, I can just copy that and paste that into my implementation. I'm going to get a few compile errors because some of the namespaces aren't declared, but we can fix that very easily. So now we can see here I have implemented my getPriceHistoryAsString on my service. I get the red squiggly underline on XML document because I don't have system.xml included on here. An XML document is in that namespace. So if I go and put that in, we see the squiggly goes away. And I have a red underline on HLP because HLP is my helpers class. And my helpers class that contained the getXML function, of course, was defined within my price history web service here. But I haven't defined it in my new cloud service yet. So I'm just going to come in here and I'm going to say add a new class. Call it helper functions. And it's an empty class called helper functions. And the code should be identical, so I'm just going to copy the code. Hopefully I got all the right brackets. Go up to my new helper functions class, which I created here, and paste that code in. And I should get a few squiggly underlines here as well because of classes like string builder and XML document. I haven't included the usings for them in the new class, and the easiest way to get the right ones, of course, is Go back to my old class. Now I could have just imported this class into my project. It might have been quicker and easier, but I just wanted to show that it's just how to construct it, piece by piece. And here now I've just included all of the proper usings, and now my helper class is actually built and it should be good to go. So now the last thing that I need to do is within my service implementation, I said HLP.getXML. That's, of course, I haven't defined what HLP is yet. So I should say here helper functions HLP equals new helper functions. So that's creating an instance of the helper functions class, and now you can see this will compile, and if I build my project, it's completed and it's running. So it succeeded. Now one thing that you just have to be aware of when running an Azure cloud service, if I set that, it is set to be my default one, is that the Azure emulator requires elevation in Visual Studio. So when I try to run it, it says it's got to run elevated. So I'm just going to save up my project. I'm going to close Visual Studio. And then I'll reopen Visual Studio as it elevated and try it again. So if I open my recent project, the price history service, hopefully that's the right one. And I set my cloud service to be my startup project, as we can see here. So I have the three projects, the service web role, the cloud service, and the price history web service. And then run it. Now we'll see the Azure emulator launches, and my service should launch within it. There it is. There's my service, and I can create a reference to this service, which I'll do in the next step. But there's one thing I want to fix, and that's I don't like calling it service 1, so I should refactor my code. So if I come into my web role, and then first of all, one of the refactoring tools within Visual Studio are really nice. So if I go to my service itself, first is the interface. Let me just close that down. First is the interface. So you can see my interface is called iService1. Within Visual Studio, I can right click on this. I can say refactor. I can say rename. And instead of iService1, I'm going to call it IPH Cloud Service. Go through and rename everything. So now my interface is called that. Visual Studio's renamed everything except the file. I like to rename the file as well. So I'm going to say IPH Cloud Service. And now if I go down to my service 1, you will see that my service 1 is implementing IPH Cloud Service. So the refactoring went nicely. And if I go to service 1 and refactor that, rename it, and let's call it PH Cloud Service. Say OK to that, rename all of them. And now I have my PH Cloud Service. I can run it. And when I run it, oh, I forgot to rename the file. So if I come in here, we can see my service is actually running. I have my PH Cloud Service. The reason why it's service1.svc is because even though I refactored my code to say PH Cloud Service, I didn't rename my file. So I can go in here and rename my file, PH Cloud Service, and rerun it in Azure, or in the Azure emulator in this case. We'll see later how to upload it as a service to Azure itself from within Visual Studio. Now we should see I have my PH Cloud Service.svc, and that's running, and I can go and I can look at my WSDL for it and all that kind of thing. So now my service is running. It's running within the Azure emulator. We're good to go with actually creating a client that will bind to this service and actually do stuff, maybe take a look at some of the data. Before I create a client that consumes the service, I also want to show just debugging and how debugging runs on the service itself. So here we can see this was my method where it's get price history as string. I'm going to set a breakpoint in there, and I'm going to run this within the Azure Compute emulator. Nothing's going to happen yet because nothing's calling the service, but it's sitting there and it's running. Here's my service address. So what I'm going to do is I'm going to open another instance of Visual Studio, and I'm going to create a client application within that. So say if I create my client application as a basic Windows Store application. So I'm going to say a Windows Store application, a blank app. I'll just call it PH Client. Say OK to that, and let Visual Studio do its thing as it creates the application for me. And now within here, within my client application, first of all, I have to add a reference to the service to be able to use the service. So if I come in and I say add service reference to the references folder, I need to give it the address of the service. The address of the service is this, running within the compute emulator. So I can copy this and I can paste it and send it off, and now we'll see it's found the PH Cloud service, so I can call it PH Cloud service as my namespace and say OK to that. And now I have a reference within my store app called PH Cloud service. There it is. So within my store app, let me just create a simple button that's going to, when I push the button, it's going to call the cloud service. So let me find my toolbox. And within my toolbox, let me drag a button onto the surface, make it nice and big. And when I click the button, I want to call the service. So how I call the service is through a client proxy. So when I created this service reference, Visual Studio creates a client proxy class for me. So if I come in here and I say PH Cloud Service, which is that namespace, dot PH Cloud Service client. So I'm just going to an instance of my client proxy called client, and I'm going to use that to call the service. So on button click, I can create an, I've just declared a client, but I have to create an instance of that, and I'm going to create that on button click. So client equals new PH service, PH Cloud Service dot PH Cloud Service client. And then because the call to the cloud service is asynchronous and I don't want to run an asynchronous event within my button click, I'm just going to do something like do get data as a void function, and then I'm going to make that function asynchronous. So now I can say private async void do get data, and here's where I'll make the call to the cloud service. So I make the call to the cloud service via client, so I can say string str data equals client dot, and if you remember, the name of my function was get price history as string, but because Windows 8 works asynchronously, the client creates an async stub on the end of that. So I'll have to say, what I have to do because it's asynchronous is I have to await it. So I say await get price history a string async, and then I can pass it parameters. I'll just, for the sake of simplicity, hard code some parameters, but if you can imagine, you could be creating a UI where the user enters these parameters. And so now my code is calling the service, getting the data, putting it into a string, and I'm just going to create another string. It makes it easier for debugging. str_test equals str_data. So I can put a breakpoint on this line once the service call has been done, and I can inspect what happened. So let's run that and see what happens. I run this app, I push the button. Now, the first thing that happens is I've hit the breakpoint, but this is the breakpoint within the service. Remember earlier, before I created the client, I set the service to run as debug. So the service is running within the Azure Cloud emulator on my machine. I put a breakpoint in that, and now I hit that breakpoint in my original instance of Visual Studio, and I can say step through here and take a look at what's going on. I'll step over that, but I'll step into this, and we'll see my function for get XML, creating the XML document, creating the data set, creating the Yahoo URI. If I take a look at that, we see it's like iFinance, and we can see that it's it's easier if I do it in here. S Yahoo URI. So resize my window here. We can see that this is the URI that if I call on Yahoo will give me a CSV for Microsoft between these dates. So I'm going to use a web client to get that. And going to load that into a stream, and my dog's barking in the background, excuse that. And you'll see my result here as a data set. And just stepping through all the code, I'm going to create XML out of all of this, and I'm going to return that. So if I come back here, my XReturn is a document. It's an XML document that's going to contain the XML. So if I say xreturn.innerXML to string, we can take a look at it, what it looks like. You can see there it's the data set. If you remember when we called the web service earlier on, not the cloud service, we saw this data coming back. So we see it's executing properly. And then when I run that, control's going to return to my client. Oh, it timed out because I was doing all that debugging. So let me redo this, pause. pause. So let me rerun the application. I'll push my button. Now I've removed the breakpoint from the cloud service, and we can see here I've done this call. I can look at my data, and there's my data. And now my data is available to my client. So what we've seen here, what we've demonstrated here, is running the cloud service on my local machine and creating an instance of creating a reference to that service within a client application, and then using that reference to get the data to the client application. So for the next step, what we're going to do is deploy this service to Windows Azure for real, and then we'll update the client to pull it from the real cloud. So for the next step, if we want to deploy this service to Azure, Visual Studio gives us all the tools to make this very simple. So if I go to my cloud service, and if I right click on that and select the publish option, I'll get this wizard. If you have a Windows Azure subscription and you've already loaded your profile settings, you'll see something like this on here. Otherwise, you can just sign in to download your credentials. So clicking on the link will take you to the Windows Azure portal where you can sign in. Let me do that right now. So you can see, so whatever credentials you use to sign up for Azure, you can use them right here. And Azure will take you to this page, and it will generate your published settings, download it, as you can see here, as a .publish settings file. You can save that, and once you've saved that, you would import it to Visual Studio, and you get your subscription level like this. So I did that earlier on, so I have my subscription level here. So I'm going to say next. So now for my application itself, my service, I can pick where I want to publish it. Here's a couple that I published earlier on. So you can see I did a test run of the PH Cloud service earlier on. So I'm going to create a new one, and I'm going to call it PH Cloud Service 2, just so you know that this one's actually working. You pick a region. I live in the West US, so I'm going to say that. Say OK. And Windows Azure will do its thing, and then you'll see you can set your production. It can be, your environment can be production or it can be staging. I'm going to put it into production. Your build configuration can be debug or release. I'm going to leave it as release. You can set up remote desktop for fine granular management of your service, but I'm just going to leave that unchecked. Make it a cloud service. Say next, targeting this, and say publish. Now there's a little bit of a UI bump that you'll see here where it says publish started, publish succeeded, and you might think it's done and it's ready to go, but it's not. It actually takes a few minutes. So if I open this, we can see the progress of the package being uploaded and deployed to Azure. And when it's done and the status goes green all the way, you'll see the website URL appears over here. So I'll just give that a few moments to finish. Okay, now we can see that it's completed, and my website URL here is phcloudservice2.cloudapp.net. I can open this up. I can take a look. We can see my phcloudservice.svc is there. I can click on that. We see something similar to what we saw when we were running it on my local machine. So what I can do now for my client, I can copy this service, and I'm going to change my client to consume that service instead of the one that had been running on my local machine. The easiest way to do this, I think, is I delete the reference to my local one. Just remember that it was called PH Cloud Service. I add a new reference. The signature is the same. So if I call it PH Cloud Service and say OK, my code should still execute as before. And if I run this, now my machine is talking to the Windows Azure Cloud, the service running in production on Windows Azure Cloud. I press that, I get my data, and it has returned with my data. Now, of course, I'm not really doing much with the data here. It's just straightforward XML data, but of course, the sky's the limit with what you can do with the data. You can chart it, you could do some kind of parsing or some kind of business intelligence on the data. But what I just wanted to demonstrate here was how to take a traditional ASMX web service and migrate it to the cloud on Windows Azure using Visual Studio, and how pretty quickly you could do that. And if I take a quick look at manage.windowsazure.com, this is the portal for Windows Azure. I'm signed into that. I can go into my cloud service. See my cloud services here. We can see PH Cloud Service 2 was created, and I have all the tools now to configure, monitor my cloud service, etc. So here's a great example of taking a web service from a traditional server and giving it cloud scale by taking it to Windows Azure, and how easily I was able to do that by using pretty much the same code that was running on a traditional server and having Visual Studio create all the metadata for me to turn that into a cloud service. And as we can see, we did that in about 20-25 minutes.